All right, good morning. Welcome back to Calculus 2. We are looking at the final exam review. We are to determine, this is problem 2a, we are to determine the volume of revolution for the region enclosed by x is equal to the square root of y plus 3 and x equals y over 2 plus 3 about the axis x equals 1. As usual with these problems, first thing we're going to do, we're going to draw a picture. Okay, so we're going to see about what that's doing. All right, so here we go. All right. Most of this is going to happen over in the first quadrant type of area. So when x is equal to 0, okay, or actually, let's go ahead and do this. When y is equal to 0, we're going to have x is equal to 1, 2, 3. So y is equal to 0, x. So we have 3, 0 as our first point. So 1, 2, 3. Okay. How about we go ahead and set up y is equal to 1. So if we have square root of 1, we get 1. So we have y is equal to 1. Okay, so x is equal to 4. So 1, 2, 3, 4. Y is equal to 1. Okay, so I'm kind of getting an idea of what this curve is going to be looking like. 2 is going to be kind of a pain in the neck. How about we try y is equal to 4, because that's a nice square root. We'll hold that off to the side for a moment. So we have the square root of 4, which is 2 plus 3, so we end up with 5. So when y is equal to 1, 2, 3, 4, 1, 2, 3, 4, x is equal to 1, 2, 3, 4, 5. So we're up here. Okay, so it looks like we've got some kind of a curve that's looking like this. Okay, the next thing we have to deal with is we have x is equal to y over 2 plus 3. You can graph this any way you please. If we go ahead and multiply everybody by 2, we have 2x is equal to y plus 6. And then we can go ahead and rearrange this a little bit. We can say this is 2x minus y is equal to 6. And then we can start thinking about some other things like we keep up here. We could say, okay, y is equal to 2x minus 6 is a y equals mx plus b. That's a real easy thing to figure out. 1, 2, 3, 4, 5, 6. Pretend that this is going to be a straight line. When let's see, when y is equal to 0, x is equal to 3. So, okay, it looks like we're going to be here and here. So we're going to try to connect the dots here. And then we're going to see where the heck these connect. It looks like I have a point here, but let's not trust my drawing. Let's go ahead and set them equal to each other so we can see exactly what's going on here. So we're going to have square root of 3, square root of y plus 3. Okay, so we have the square root of y plus 3 is equal to, what's my other function? My other function was y over 2 plus 3. Y over 2 plus 3. And we're just going to go ahead and solve this equation. The 3's will cancel. So here we have 2 square roots of y is equal to y. Square both sides, so we have 4y is equal to y squared. We'll just square both sides here. And then we have y squared minus 4y is equal to 0. We'll have y is equal to 0 and y is equal to 4. Okay, which is, I think, what we ended up finding with this thing anyway. Oh, look at that. Y is equal to 4. So we did end up 1, 2, 3, 4. And then we have our x values here. Okay. So it worked out. My drawing was reasonably close, and we're kind of okay here. So what we're going to do is we're going to do method of disks. So we're going to look at this. We're going to say we'll integrate it with respect to y. So we'll go from 0 to 4. Okay, we're integrated with respect to y. Now this is a sideways type of a thing here. Okay, so we're rotating around this piece right here. So what we're going to do is we're going to say we have to go 1, 2, at least 2. Okay, so we're going to have 2. So the value is going to be 2 plus whatever we're going to be figuring out here. So that's how we're going to figure this thing out. Okay, so we have to go 2 more from where we are. Okay, so let's see here. What do we have for this? Okay, so we're going to say that we have, let's see. So we're going to go ahead and we're going to say we need our right minus our left, okay? And our right is going to be the square root, okay? And we've already got a thing here. So actually, we have to go 2 more that we're going to have here. So we don't really need this piece right here. We're just going to say that this is going to be the square root of y plus 2 squared minus y over 2. And then instead of plus 3, we already have a head start, right? So we only have to go 2 more. So we have y over 3, y over 2 rather, plus 2. Okay. squared dy. And this is what we're going to try to integrate. Now, I can't go off and integrate this. I actually have to go through and deal with the arithmetic for figuring this thing out. So we're going to do y plus 2 by square root of y plus 2. We'll go ahead and multiply this out. So we have square root of square root. That's going to be y. We have 2 square roots of y here, 2 more square roots of y there. So we have 4 square roots of y, plus lasts are going to be 4. Okay? Now we have y over 2 plus 2 times y over 2 plus 2. Same thing's going to happen. So we're going to get a y squared over 4. Here we have a 2y over 2 and another 2y over 2. So we have this guy, not this guy, we have this guy. So we have a y over 2 times 2, okay, plus this piece, the inner one, it's 2y over 2. And then finally we have a plus 4. So we end up with a y squared over 4. Some stuff cancels, so we have plus 2y plus 4. Let's plug it back into what we were starting with. So we have pi integral 0 to 4. We have y plus 4 square roots of y, that y, plus 4 minus y squared over 4 minus 2y minus 4. Well, that's a little convenient. So these pieces go away. That's nice. We have y minus 2y. So let's see what we got to collect as far as our positive numbers here. So we have 0, we have pi integral from 0 to 4. Here we have 4 square roots of y. Okay. Y minus 2y, that's minus y. So this is gone, this is gone. And the only thing left I have is y squared over 4. So I'm going to make this into a calculus problem rather than an algebra problem. So we have pi integral 0 to 4 y to the 1/2 power minus y squared over 4. Okay. Easy enough. It's polynomial. Let's just integrate it. So we have 4 times y to the 3/2 times 2/3 minus 1/2 y squared minus y cubed. And then we have 3 times 4, which is going to give me 12, going from 0 to 4. Not too bad. So here we have 8/3 times y times 4 to the 3/2. I'm just going to plug in the 4 here. Minus 1/2. We have 4 squared here. Okay. Minus 4 cubed over 12. Okay. So let's see here. We got 8/3. This is going to, another fancy way to write the 3/2 is 4 root 4. Okay. So we could say this is going to be 4 times 2. That's going to be 8 minus half of 16 is going to be 8. And then we have minus 64 over 12. We could clean this up a little bit. We have 64 over 4 times 3. 64 is 16 times 4 over 4 times 3. I just took this out and I rewrote it as a product of its factors. So it would be easier for me to figure out. Okay. So we would have, this is 64/3, 8 times 8, minus 8 minus 16/3. Okay, that's not too bad. So get your handy dandy calculator out. We've got 64/3 minus 24/3 minus 16/3. And we can go ahead and figure out what's going to happen with that. 8 is a fancy way to write 24/3. Okay, so let's see here. I've got, do I have a calculator? I do. I have, oh, can't show you because I turned off my video. I've got my TI 30X2 here, so I'm not going to have a fancy calculator. And since everything's in thirds, I'm just going to say 64 minus 24 minus 16. And what do you know? I end up with 24/3. 24/3, which is a fancy way to write 8. So don't forget the pi out in front. My answer here is going to be 8 pi. So my answer, 8 pi. And there we go with that problem. And that is how you do a volumes revolution. And we graphed it. We set everything up. We multiplied everything out. And we finally got to the end of it. Okay, so it's a bit of a long problem, but all the pieces are there. Okay, draw a picture if it's going to be kind of weird like this, and let me know what's going on with everything. Okay, thank you very much for watching my video. Good luck with the test, and take care.